Okay, continuing on with this worksheet. Number 6, a function is graphed below, and they give you this function. It's this little wavy line here. We never really talked about what that is, but it doesn't matter. They're not asking us what type of function that is. They're saying determine whether the function is increasing or decreasing at the following intervals. So first things first, remember, trust your gut instinct on what it means to increase on a graph. To increase on a graph from left to right, increasing is going up and decreasing would be going down. And that's key to know that it's from left to right. So from left to right, increasing means go up, decreasing means go down. So once you have that definition, then we got to look at the different intervals. When we're talking about x, we're saying x is less than 2. Well, where is x on this graph? Well, on this particular graph, the -2 is right here. It might be hard to see in the video, but you look on your paper. So they're looking at this section right here, this up and down. Remember, when it's x equal to 2, it's an up and down line. So whenever it's less than 2, they're talking about things to the left of 2. They're thinking less would be to the left. So from this section, this little section here is what we're looking at. From here to here, we're asking, is that increasing or decreasing? Well, is it going up or is it going down? Obviously, this line's going down, so we can say that that's decreasing. All right, between negative, so this is a funky way of saying between. X is between -2 and 0. So here at our -2 line and the 0, x equal to 0 is on this axis. This section of the graph now is what we're looking at. So this section, if you look at that, notice the line is from left to right is going up, so we can say that that is increasing. And then finally, anything bigger than 0, so x greater than 0 means anything to the right of that line. So this function comes and ends right there. So is that decreasing or increasing? Well, the line's sloping down, so we can say that is decreasing. All right, and that's all there is to that problem, knowing what increasing and decreasing means and knowing how to pick the intervals based on this notation. All right, and then finally, the last part of this problem, they throw in a little curveball here at the end. They say for the entire function, and they're calling it f of x, this line is named f of x. They're asking you, is f of x greater than 0 or f of x less than 0? Well, remember, if x is the input, or left to right on the graph, our inputs are always the left and right. So x's move our graph left to right. Then f of x would be the output, or up and down. That moves us up or down on the graph. Remember, another f of x is just a fancy way of saying the y-coordinate. So y-coordinate moves us up or down on the graph. So when they're saying f of x greater than 0, well, y is 0 at this axis, the x-axis. So greater than 0 would be anything above this axis, so that would be greater than 0. Anything below this axis would be less than 0. So they're asking, well, is the function above or below this line? And obviously, if you look, the whole function is down under that line, so it's less than 0. So we will circle f of x less than 0, or you can write f of x less than 0 there. All right. So moving on to number 7, what are the solutions to 6 over 5x squared equal to 30? So basically they're asking us solve for x. So whenever we have an equation like that, we've got 6 over 5x squared, I'll write it over here in the margin, equal to 30. Remember, the first thing we have to deal with to get x by itself, we have to get rid of this fraction. So what we have to do whenever we have fractions, if you're right, if your first instinct is to say to divide by 6/5. But remember, when you divide by fractions, what you're actually doing is you're multiplying by the reciprocal. So what we're doing is we're flipping that fraction end to end, and we're multiplying by 5 over 6. Another way I like to think of it is if you throw him over this equal sign and he lands on his head, that's what I have to multiply both sides by. So here, I have to multiply by 5/6. And the reason why we do that is because on the diagonals, the 5 will cancel here, the 6 will cancel here, and we're just left with 1x squared over here on the left. So x squared is equal to, And then remember to multiply fractions. If we have a whole number, we put it over 1. We multiply the tops and get an answer. So that would be 150. And then multiply the bottoms and get an answer. 1 times 6 is 6. So it would be 150 divided by 6, whatever that is. Another option when you're multiplying is to cross reduce before you do it. 6 will go into 31 5 times. So this can reduce to 1. This will become 5. 5 times 5 is 25. All right. And then finally, when we got x squared, to undo a squared, we have to take the square root. So we square root both sides, and we get x is equal to square root of 25 is 5. But remember, when we have x to the second, we're always going to have two solutions. All right. If you think about taking the square root of something, if you do 5 squared, 5 times 5 will get 25 back again. But also remember, if you have negative 5 times negative 5, that also equals positive 25. So anytime we take the square root of a number, it has both a positive and negative root. So we can say plus or minus 5. And that is the answer to number 7. All right. Moving on. Number 8, it says, at the beginning of an experiment, the number of bacteria in a colony was counted at the time t equal to 0. The number of bacteria in the colony t minutes after the initial count can be modeled by the function b of t is equal to 3 times 2 to the t. And that's not 3 times 2 to the t. This t should be in the exponent. That's a mistake in my thing. And the reason for that is this is an exponential function. This is 3 times 2 to the t. All right. So 3 times 2 to the t. What is the average rate of change in the number of bacteria for the first 4 minutes of the experience? Key word there, rate of change. Rate of change is a fancy math word for saying find the slope, or what is the average slope. If we graph this, that's the steepness of the line of whatever we're talking about. So in this case, we're talking about the first 4 minutes. So we're going to get an average of the slopes between each point. So we're going to need points to take the average from. So we're going to make a little table. All right. On the left, it's always the input thing. Usually this is x and y, but in this thing, there's no x and y to be found. Remember, the input is the thing inside of the parentheses. So on the left here, we're going to have a column for t, and then our output is the function itself, b of t. Okay. So in this function, then t represents the time. B of t represents the number of bacteria. All right. So they start at time equal to 0. So we're going to start there, and they go up to 4 minutes. So we're going to have a value for every minute. So we're going to have 1, 2, 3, 4. And then we're going to take these values, and the long way to do this is to take these values, plug them in for t, and get answers. All right. The quick and easy way to do this is to go into your calculator. We'll clear out our old function here. All right, so you'll go into the calculator, you'll hit this y equals button. We'll clear out our functions, anything that's there. We hit clear, enter, and clear. And we'll come back up to y1, and we'll input our function into the calculator. Our function is 3 times 2 to the exponent t. All right, and you can type it exactly the way you see it. Put the parentheses around the 2 and everything there. So we'll do 3 parentheses, 2 parentheses, upside down v gives us the exponent. And in this case, we're not going to put t. We'll just assume that since t is our input, x is what we call the input, we'll use the x button. If you use any other letter, there are other letters. You can get t by hitting the second and whatever button has t down here. I'm not even sure where that's at. But you can get t if you want, but if you do that, it's going to give you an error. You need to put x in there. So it's 3 times 2 exponent x. And then remember, the easiest way, we're trying to get a table of values here. So instead of hitting just graph, we hit second graph, and that gives us a table of values. So when x is 0, y is 3. So down here we can write 3 beside a 0. When x is 1, y is 6. So beside of 1, we can write 6. When x is 2, y is 12. So we'll write 12. When x is 3, y is 24. And then finally, when x is 5, y is 90 or 48. Or when x is 4, y is 48. So what basically is happening is you're just doubling in size every time. So they didn't ask us for a table of values. They asked us for the average rate of change. So what we need is another column here for our rates of change, because we need to find the slope between each point in order to get an average. So we're going to find the rate of change between these two coordinate points. Remember, this is the coordinate point 0, 3, 1, 6. And if you remember, the rate of the slope between any 2 points, that's y2 minus y1 over x2 minus x1. All right. So this is a fancy way of saying take the two y coordinates and subtract them from each other, then divide it by the two x coordinates and subtract it from each other. And remember, the x has to be in the same order that you did the y. So if you do 6 minus 3 on the top, you have to do on the bottom 1 minus 0. You can't do 0 minus 1. So just for the first one, I'll write that out. Your slope here for this one is going to be 6 minus 3 on top. That's the y. And then on the bottom, your t is 1 minus 0. So 6 minus 3 is 3. 1 minus 0 is 1. So that's 3 over 1, or 3. All right? But notice what happened here. X was equal to 1. If you look over here and you start subtracting these x's from each other, you're noticing that you're always going to have 1. For this particular problem, you're always going to have 1 there. So the easiest way to get the slopes, the shortcut, is just to subtract these b of t's from each other, and that will be the slope. 12 minus 6 is 6. 24 minus 12 is 12. And then 48 minus 24 is 24. All right? And then remember, to get an average then, what we have to do is add up all these numbers and divide by the number that's there. So for our average, it's going to be 3 plus 6 plus 12 plus 24. Divided by, well, there's 1, 2, 3, 4 numbers there. So to get the average, then you'd add those up and divide by the number that's there. So in our calculator, if you went out of the screen, you hit second mode. And then you'll do 3 plus 6 plus 12 plus 24. Get an answer. That's 45 divided by 4. So our average is going to be 45, and we'll take that divided by 4. It'll give us 11.25. All right? So if you have any questions on that, bring them to class.